So what we're looking at here is my logged in profile. If I log out real quick, you'll see the landing page, which gives you the option to sign in or sign up, which will open a new little window here. And I am going, and you can either sign in through GitHub or Google or with your own email address if you want to do email and password. And you can select to receive news and updates or not. I'm going to select logging in through GitHub. Try to open up a new window here. All right. And from this page, I can create a new project. So today we're going to run a meta-analysis about cognitive control in older adults. So how is cognitive control represented in the brain for older adults? So when I create a new project, it's default untitled. So if I have an intention of what I'd like to study, I can click edit on the title here and save it, and I can add in more information with the description. Say my meta-analysis demo about older adults. And I can hit save here. And on the main project page, what Alejandro just went through, we have it represented on our platform directly where you have search and curate. Let me move this up so I'm looking a little bit higher. Where we have search and curate, um, extract and annotate, and specify the meta-analyses at the end here. So to get started, we're going to search and curate, and we're going to choose the Prisma workflow, which stands for the preferred reporting items for systematic reviews and meta-analyses. I know we're throwing in a bunch of acronyms and word soup. I swear it does sink in eventually. So from here, we're going to be presented with this screen where we have 4 categories which mirror the Prisma guidelines, where we are going to first import studies, so that we have studies to actually go through this process. So I'm going to click import studies here. We have a few options to import studies, whether it's searching on our database on Neurostore, which Alejandro mentioned, which we'll be doing today, but you could also import studies via PubMed, or if you have a sleuth file, because if you've used BrainMap before, then you'd be familiar with this file format. Or if you are using a citation manager such as EndNote or Zotero, then you can export that in a bib or a .ris file, and that can also be imported into our platform with these different options. Or if you're shared a study or information such as coordinates that wasn't published and not available in any other format, you can manually create a new study. We're going to select Search Neurostore. This will give us access to our database here, and I am going to use a couple keywords. For cognitive control, we are going to look at it through multiple tasks. So first I'll say, let's say Stroop and aging. There we go. So let's say that gives me 106 results, and I can look through them here, or I can, when I'm done looking through them to see if my search was somewhat correct, I can import the 106 studies through this page. And here again, I can look at the titles and look at links to either view it in Neurostore or through an actual PubMed link. And I can see if the article looks relevant or good enough for me. But this is not the main stage where we'll be reviewing the articles. This is just for making sure that you typed in the right terms. Okay, so after I import the studies, we are back to this curation stage where the first one is identification, which is just to identify duplicates. Since we did not identify any duplicates, we can promote all of the uncategorized studies, which are currently in identification, and move them to screening. And it'll ask me if I want to continue, and I'll say yes. So within screening, we are primarily looking at titles and abstracts to make sure that they are relevant for us. So I'm looking at this study right here. This one's a meta-analysis, and we will only want primary research. So I can say this one's irrelevant because it's a meta-analysis. And so if I look here in excluded, I have different reasons that I can state for why I excluded a certain study. And I can edit this to say, let's say I found a meta-analysis, but then I found a systematic review later, but I didn't want to put them in different categories. So I could edit this to say systematic review / meta-analysis and save that, and that updates the tag here. So if you have gone through the process of screening hundreds of studies before in a meta-analysis, you will realize that your reasons for exclusion may evolve as you go through the process. And we want to be able to accommodate that. So that's why we allow you to create these categories and edit these categories for exclusion so that you can have the most information to you when you're revisiting this process, say several months or several years down the line to ask why you excluded a certain study. And let's say I am looking through these columns, and it appears that I have a lot of studies that don't involve older adults. So to confirm that, I can click on this plus minus columns here and add in a new column where I can actually search called title. So if I click on this upside down triangle filter column here, I can search for, say, young. And I can see that there's a couple studies that are just following participants that are not older adults. So I could do this and say irrelevant and say no older adult. So now I have two different criteria in which I am excluding studies from, and that might evolve as I discover new studies. Let's say I want to discard this entire search. Let's say I didn't like this search at all. So right now, if I want to see all the studies again, right now there's a filter. So I exit on that so I can see all the studies. Let's say I want to start over and I disliked everything, this entire search. I put in the wrong search term. I wanted a different search term entirely. So I can delete this import and start fresh. So in case you ever start a project, you ran a search on Neurostore, and then as you're going through the studies, you realize like none of these studies are relevant. So let me do a better search for my purpose and do older adult. Let's do Stroop and older adult. And I can search here, and then here are 18 studies that are likely very relevant for my meta-analysis on cognitive control and aging. So none of these have duplicates, so I can promote them all to screening and go back here. And let's say, since I'm studying cognitive control, I might want to have other tasks I would like to include. So another common cognitive control task is the flanker. So I can do that exact same search, but replace Stroop with flanker and older adult. And that gave me 9 more results. So I can import these 9 studies. And looky here. We automatically detected a duplicate because there's one study that existed in both searches. And we can keep track of both searches that we have in here in the import section. So we can see that one study already exists. So we don't need to review it, or we don't need to have it inside our screening section. So we'll promote all the other uncategorized studies into our screening section. And from here, we are interested in older adults and specifically the traditional bold contrast. So we're not looking for connectivity studies. So I'm going to search for connectivity, and I'm going to see what studies are likely just related to connectivity. So this one looks like connectivity, and this one looks like connectivity. And so all of these that mention connectivity in the title, I'm actually saying I'm going to select all of these, and I'm going to say that all 5 of these are relevant. And I can say that they're relevant for say that they're about connectivity because I just want bold contrast. So now I've excluded all 5 of those studies because they are about connectivity. And otherwise, if I have looked through these studies and I decided that, oh, these ones look good, I might want to add in just a few more studies so I can get a good sampling. So I'll also look at the MBAC, which is another common working memory, could be argued to be executive function cognitive control, right now, and older adults. Adult. And that will get us a few more studies. So I'll import those, go next, and we have another duplicate. So I'll get those through screening. And imagine that you went through all of these titles and abstracts, but for today, for this demonstration, we're not. We're going to select every study and promote them to the next stage of eligibility. Okay, so now we see that screening is 0 and that eligibility has 44 studies. So within here, we can now go into a little bit more detail of what we would like to filter on. So the extracted features that we have from these studies include, say, minimum age. So, so if the minimum age is now added as a criteria, and if I want adults that are over 60, then I want to be curious about any studies that report a minimum age being less than 60. So I'm classifying 60 as being an older adult. So this one has the minimum age being 60, so that one's okay. This one I see 50 being a minimum age and none of the other ones being reported. So that one is a study that I'm curious about. And again, if I'm curious about it and I want to figure out why it's only reported 1 or 2 of the group's ages or sample sizes, then I can open up the paper here in the side panel and review it so I can get that information myself. And if I looked at that paper and decided, hey, this paper doesn't qualify, then I can give it another reason to exclude. I can say participant's too young. And that, again, will be a specific reason that I've created, but I can also use these other criteria as well that we've given you access to. So either you can access the paper, or there's not enough details in the paper, or if you've decided that you only want sample sizes, say, of greater than 10 or 15 for it to count. So it could be a limited rigor, or they use statistical methods that you don't agree with. Or if the paper is, you thought it was relevant, but it's not inside the scope of what you're looking for. So you can use all of that criteria to decide how you want to edit the studies. So I use the minimum age here as one filter so that I could look at flag studies that are that report less than 60. I could also look at diagnosis if I care about only having healthy adults. So anything that's listed, I'll remove that filter. Anything that's listed as not healthy could be a flag that I use to boom, 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 to decide whether or not I want to include the study or not. So generalized anxiety disorder. Maybe I don't want to include participants that have generalized anxiety disorder. And I would perhaps not want to include studies that have participants with major depressive disorder. So again, I can click on this, look at the some of the experimental details, and or open up the paper to the side so I can read the paper itself and decide that I want to exclude it because of psychiatric diagnosis. Okay, so we're going to select all the rest of the studies just for the sake of time and include them into our meta-analysis. So what you might have noticed after I hit include is this button starts blinking and getting flashy. So this is signaling that we are now finished with the curation and are ready to move on to the next stage of extraction. So that's going to be the stage where we look at the coordinates and decide which contrasts, analyses that are within the studies that we want to include in our meta-analysis. Because you can imagine within a particular paper, let's take a look here. So take a look within this paper, maybe we are interested in this contrast, but not this contrast. So we can uncheck this box, which is what we call our annotations. And annotations functionally serve as a filter for what analyses you want to include in the meta-analysis. So within a paper, it might talk about, or it might have contrasts for both, say, younger adults and older adults, or for the generalized anxiety paper, it might have a contrast that's including the patients with generalized anxiety and another analysis that does not include them. So we want to have a method that allows us to deselect those. So I'll deselect that one and I'll hit save, and that will have my annotation saved. And I can add in new annotations that can either be a string, such as that being a category. So one for me could be if the contrast is, say, older versus younger, that could also be a Boolean, and I can add that, and that will add it here on this page. And it will be added for every study that I look at from here on out. So I'll hit save. Imagine if I looked at the paper again. So here again, I can open this up in a split view and view the paper as I'm going through it as well. Elsevier thinks I'm a robot. But, ooh, perhaps I've been visiting their website too often. But here, again, you can go through the paper and look at the tables that are included and map them to make sure that they correspond to what you wanted to extract. Um, so we do have a table here for the frontal lobes, region side, parietal lobes. Okay, so we um, see these different criteria, and we might want to map that onto the coordinates that are reported here. And let me close this so we can get a better view. And we can edit coordinates by, say, adding a row. Say they missed a coordinate. I wanted to say 9, 31, 42. So let's say if that was a coordinate that I wanted to add, then I could add it here. Um, and if I wanted to say, oh, actually, I don't need that row, I could delete that row. And if I wanted to add in a bunch of rows because I knew I was going to import, say, 10 coordinates at a time, then I could select the 10 coordinates right there. Uh, okay, so I'm not going to hit save. I am going to uh, move on. I'm going to say this is good to go. And if I don't hit save, it's going to try to ask me if I'm sure that I want to continue. In this case, I am sure I didn't make any edits that I wanted to make there. And we can see for this paper, there are no coordinates reported for this analysis, which was extracted for the version that we wanted. I could switch to a different version. Let's see, which just has one analysis, but I want the more recent version, and you can see here that this one was modified in December. Okay, so since this one doesn't have any coordinates, I can check the paper to see why there's no coordinates reported there and see if that makes sense. In this case, I am just going to delete the analysis, and then I'm going to hit save. Okay. And then let's say I did that for all of the papers, and I am going to take another shortcut here and mark all of these as complete. Boop. All right. Does anybody have any questions about extraction or how to go through extraction at this time? I'm going to take a pause. All right, then I'll move on to the next stage where we can now advance since we have all of the studies completed. I'm going to hit advance. And from here, we can proceed to the meta-analysis page. So we've now extracted and annotated all our papers, edited coordinates when we needed to, added in new columns of annotations for things that we'd like to mark, for filtering the analyses later on. And by later on, I mean right now. Um, as Alejandro said, we have choices for different algorithms. I'm not going to cover the algorithms today, nor am I going to cover the different correctors that we have. For your first meta-analysis, you can choose the defaults. Here is pulling from those annotations that we had earlier. So I had the included column or the older versus younger column. And this will tell me like, oh, all of the analyses and all the analyses from each of the studies that I included. So you can use that to make sure that it looks accurate. And I'll hit next here. This will be naming our meta-analysis for us and giving a description. You can edit this to name it something that's more specific to your use case. And this will be a summary of the parameters that were selected for this meta-analysis. So I hit create, and we are given three options. I'm going to select the AWS option right now. And that will kick off a run on AWS, which will run the meta-analysis for us, what Alejandro was saying about creating the bundle and using that data set that was created and the specification that we just created. And it will send that all to AWS, and that will process the meta-analysis for us and output here. For other options, if you wanted to run it again, we have the option to use Google Colab. So you'd copy the meta-analysis ID here, then open Google Colab, and that will load eventually. Paste here. And you'll get this notification. You'll say run anyway. And you can set the environment and run the meta-analysis. I won't run the meta-analysis here since it's already running in AWS. But if you wanted to have an option to explore the results and to run other follow-up analyses using Nightmare, which is the open source package that we maintain, that allows you to run lots of different types of meta-analyses and other meta-analysis adjacent activities such as decoding. And if you want to have control over where your data, or I guess if you want to only keep your data locally and on our web server, then you can run it with this code snippet with Docker if you have Docker installed on your computer or on whatever machinery that you're using to run Docker. And it looks like that it succeeded, and it will refresh the page and give us the results. So this is the end of all of our work, where we have a nice little thresholded map where you can play with the thresholds and see what these brain areas are, and then you can download either this image or the actual Nifty that goes behind the image, and you can do with that image. You can play with that Nifty file as you will for any downstream analyses or anything that you'd like to do again. All right, so that's the entire meta-analysis. Was there any questions that people had?
Someone asked how you delete a project.
Yeah. We just added that, or I guess that functionality is going to be added by the end of the month in our next release. That was a good question. Yes, we have that and we have it merged. So it'll just be on our next deployment cycle, which will be in the next week and a half or so. What other questions do people have?
So somebody's asking about if we have a limit on the runs on AWS.
Currently no, but we are monitoring the usage of AWS, and we will likely institute a token system where you'll have a certain number of tokens that correspond to a certain number of meta-analyses that you can run per month on AWS. But right now, we are letting people use it as freely as they want so that we can get more feedback on how it's being used and how to strengthen any edge cases that we haven't thought of. Thank you for feeding those questions, Alejandro. Any other questions?